Hi everybody, welcome to Test 1 review for pre-calculus. You will see on the top we have the list of the topics that will be covered for this review. And as we go along, I will check up each item on the list. Alright, let's go straight to the first one. Determine whether this relation is a function. So first we look at the first component of each of the order pair, and we see that they all different, and those are the domain in the domain. So first we say it is a function. All of the first component are different, so we write out the domain as a set -4, -3, 0, 3, and 5. As a set, we can write equal sign also. And then the range, the set of the second components, 12, 5, -4. Already have 5, so we don't need to list it again, and then 21. So we just like that. Right. Determine whether y is a function of x. This will be not a function, because if we solve for y, we have to take the square root, and that will be plus or minus. Right. We're not going to do that. Right. So so I will do like that. I will strike over the topic on the list, and then I write out what numbers it is on the test review. So you get used to it for the rest of the review. It will be like that. Next, combination of functions. That will be number 5. Right. So we just add, multiply, divide, subtract of the function. Then we just subtract the function pretty much. So 4x minus 7 minus ax plus 5 . Right. And if we write the domain of the combination, the domain of the combination will be the domain, the intersection of the domain of each one of them. So this one is all real numbers, all real numbers. So the whole thing is all real numbers. Except when we're dividing, then we don't want to divide by 0. But this one, when we add, subtract, or multiply, it will be the intersection of those two domains. So all real numbers, all real numbers. Intersection is all real numbers. This topic is pretty straightforward, so I just go over that rather quickly. Later on, when we have more complicated problems, then we spend more time on those problems. Right. Next, we have the domain of common functions. That would be 3 and 4. So there are two things we need to watch out for now. When we have logarithmic functions or trigonometric functions, there will be a lot more, but for now we just need to keep this in mind. So we need to have the denominator not equal to 0, and if we have the square root or any even root, I just write like this, an even root, and whatever we put inside an even root have to be greater than or equal to 0. So that is the second thing we need to watch out for. So only those two things for now. So first we have this, the denominator is x squared minus 49, and that cannot equal to 0. So we solve for x squared not equal to add 49 both sides, and then we take the square root. When we take the square root, there is a plus or minus of that. So x not equal to plus or minus square root of 49, which is plus or minus 7. So we say x not equal to plus or minus 7. We can write like that, or the number line. Or we write interval notation. Yeah, any of this is fine. Bottom line is, if we have denominator, it cannot be equal to 0. That's the first rule. The second rule is that if we have an even root, in this case a square root, inside of that have to be greater than or equal to 0. If we solve for x, we're just gonna add x on both sides. And pretty much we have that x less than or equal to 10. So we can write it is x is, oh, it's better yet just write x less than or equal to 10. I mean, this is better. So it will be less than 10, and it can be equal to, so that will be the square bracket. So we can write this, the graph or the interval notation, all three of them represent the same thing. That will cover the domain of some common function. By common function we mean rational function or radical, or with the square root, even root, odd, or any root. If it is an odd root, we don't have to worry about this. It's only applied for an even root. And if we have a polynomial function like something like this, of course the domain will be all real numbers. Only watch out for these two things, denominator and inside an even root. Right, a little different on that list. Now we go odd and even function. That will be 9 to 12. Right. odd and even function. I'll go to this graph in terms of function first. Definition: an even function is where we have f of negative x equal to f of x, and an odd function where we have f of negative x equal negative f of x. The only difference between those two is this minus sign. Both of them start with f of negative x, so that's where we start. For this one, we start with f of negative x. On three negative signs, that will be negative 3x squared minus 5. And that is exactly as the original function. So that's why this one is even. Or we can also do it like this. We see that x to an even power, so that one is even. 5 is also even. So the whole thing is even. Notice that the negative 3 in front of it does not affect anything. So, loosely speaking, we can say this are the even term. We will have x to an even power, a constant, or absolute values of x. Those things are even. Of course, there will be some of the trigonometric function, but we'll talk about that later. And then odd will be x to the odd power, or we have an odd root of x. So we have an even power, so that is even. A constant is even. Even and even, that will be even. When they subtract each other, it's still even. Right. But of course, the definition certainly works. Now we go with this. We start with the same thing. This one definitely we have to use the definition. So we have negative x for x. Negative x will end up with negative x. And we have x squared minus 4. Obviously, it is not the same as the original function. So we say it's not equal to the original function. So it is not even. What we do is we need to manufacture the minus sign here. So just put the minus. If we pull the minus out, we're left with x and x squared minus 4. And that is exactly the original function. So this equal to negative f of x. And that's why this one is odd. We have to use the definition on this one. If it is a polynomial or a combination of all the even terms, it will be even. If it is a combination of odd terms, it will be odd. And if we have one of each, at least one of each, it will be neither. Right. Now in terms of graphs, the even function will be symmetric. On the y-axis, and an odd function on the origin. So graphically, this is what we have. definition, this is what we have, and those are the terms. Some example, that constant absolute values even powers will be even. Of course, 1 over x to an even power is also even, but those are some of the terms. Right, now we look at this graph. This one obviously is not symmetric with respect to the y-axis, because if we fold this in half, they are not the same. Next, if we take a point here and we go across from it, it doesn't look like there is a point in here. So this one has no symmetric. So this one is neither. It has to be perfectly symmetric. This one, if we fold this in half on the y-axis, they will be the same. So this is y-axis. Y-axis symmetry. It will be even. It has to be perfectly symmetric. I will have some more example here. So this one is perfectly symmetric on the y-axis. So this one is even. Likewise, this is also perfectly symmetric on the y-axis. So this is even as well. This one is off. It's not symmetric. It is symmetric on this line, but it is not the y-axis. So this will be neither. This symmetric with respect to the origin, because if we have the point here going across from it, there will be another point there on the graph. Same thing. So if we pick a point and we go across the origin, and we have another point on the graph, it is symmetric with respect to the origin. And if it is perfectly symmetric like that, it's going to be odd. This one is not. It's off. So it's neither. And this is also neither. So it has to be perfectly symmetric. Like I could do like the sine function. That is not. A sine function is not. Right. So let me check off that list. I mean that item on the list. Right. Next, average rate of change. What's that? 15 and 16. I'll do 16. What's wrong with this? Average rate of change. That is the slope of the secant line. So let me draw a little graph here. So we have the function, and there are 2 points on the graph. x1, f of x1, x2, f of x2. And if we draw the line through these 2 points, that is called a secant line. So we have the slope of that line is equal to the average rate of change. Term of the formula will be f of x2 minus f of x1 Or we can use B, A, or B and A. It doesn't matter as long as we have 2 points from x1 and x2 and the values of the function correspondingly. Let's say 16 with f of x2 minus f of x1, x2 minus x1. We have 2 points. So let's say x2, x1 is 2 and x2 is 8. And we just need to put f of 8 minus f of 2 over 8 minus 2. So we will have square root of 2 times 8 minus square root of 2 times 2. Oops, I have space. So yeah, we put 8 in for x, and then we put 2 in for x, and subtract them. Over 8 minus 2 is 6. So we have square root of 16, which is 4, square root of 4, which is 2. So we have 2 over 6, which is 1 over 3. Yeah, so evaluate the function at those 2 points, and subtract them, and then divide by the difference in x values. So that is 16, and the average rate of change, pretty much this formula. Or the slope of the secant line. Increasing, decreasing, constant or local max min. This is pretty simple. Just look on the graph and we find out where the function is increasing, where it is decreasing, or like so note the only thing that's very important is it is on an interval of x. So when we say it's from -3 to 0, that means from -3 to 0, and we have the graph. The x values go from -3 to 0. So that is a constant. Right. I can also ask you where the function is increasing. For example, I will write a question here. So where the function is increasing, the question could be like that. And then we look at this, we say it is increasing on this part of the graph. But notice that we only write the x values. X value corresponding will be from -3 to 0. By the way, sorry, it was -3 to 0 and not 0 to 3. Never mind. Sorry about that. So from -3 to 0, it is increasing. So we say -3 to 0. Notice that this is an interval of x. Or we should say an open interval of x, meaning it's going to be only and always parentheses. So from that, it is increasing. If we want to write decreasing, then we say decreasing on this portion, meaning it goes from 3 to infinity. Again, an open interval of x. So I might give you a graph and ask you where it is increasing or where it is decreasing, and you just write out an open interval of x that corresponding to increasing or decreasing. Local max and local min, that's pretty straightforward. All we just need to do is just write out the point. So like that is a local max. It is easier to just write out the point. That is the local mean. And notice that unlike the previous example where we talk about an interval, those are points. So of course, this is not an interval. It is a point, and it is a point. Or like this, we say 17. We say local max is this one. X equal to 0, y equal to 2. Local mean. This x equal to -3, y 0, and x equal to 3, y is 0. So we just need to write out the point for the local max and local mean, and that would be good. Let's not update it. Put the numbers on it. Next we have piecewise function. On piecewise function, you will be asked to evaluate the function or graph the piecewise function. So we look at 18 to 20 here. To evaluate the values of the function, this is pretty simple. We want the values of f of x when x equal to -5 and the -5 is less than -3. So this condition is checked, which means we use this part of the function. So that will be equal to negative, and now we put -5 in for x. So here we have 6. So just like that. Just make sure the numbers in the parentheses have to be true when we substitute into the condition, and we only choose the condition that it is true. Right. 19. Our phone plan, they set a charge 100 minutes. The first 100 minutes is $20, and after that the second 100 minutes is 7.5 cents a minute. So to get 200 minutes, first we're going to pay $20 for the first 100 minutes, and then because 200, that will be next. I will write this. This will be for the first 100. And then plus, next we have 100 minutes times 7.5 cents. So that will be for the next. By next, I mean after 100. The charge for 250 will be the same as the first 200 minutes here. As multiply. But then we have to add 50 more minutes at this rate. Right, the calculation is not important, so I just leave it at that. Now construct the function. So the function is this. If we call less than 100 minutes, it's still going to be $20. If it is less than or equal to 100 minutes. Now, next, we still have to pay 20 minutes. $20 for the first 100 minutes. Then whatever over 100, we have to pay at 7.5 cents a minute. That is if it is between, that is no equal sign here, and then equal sign here. From 100 to 200, we only have to pay whatever we use from 1 to 200. And then if we use more than 200, we have to pay that for the whatever we use from up to 200. And if we have more than 200, then definitely we have to pay 100 minutes at this rate. And then whatever over 200, we have to pay at the 10 cent. So we have that. Of course, we can simplify this, but 20 minutes, $20 for the first 100 minutes. The next 100 minutes at that rate, and whatever left will be at this rate. So it will be like that. Right. Next, we will graph a piecewise function. First, we look at this and we see that the gap of the piecewise function at 0, so it's going to be right this line. Next, we graph each one of them. Look at square root of 3, square of x plus 3. I'm going to do that in pencil because I might need to erase some. So square root of x is this, plus 3 will go up 3 units. So that's good. And this is exactly what we want, greater than equal to 0. So yes, that's what the graph of the function looks like. And there will be an arrow. Next, negative x plus 2. That is the linear function. So we just pick some value for x. I choose x equal to 0, y equal to 2, x equal to negative 2, y equal to negative 4. So we have this 2 point. Sorry, this 2 point. Look for the eraser. Right. Next, 0 and 2, and negative 2, negative 4. So we have that line. Let's do that in pencil. But notice that this function only for x less than 0, so we only have this part. That part of the function we really don't have. And finally, the equal sign will go with the square root. So we have the dot here and an empty circle here. So that is the piecewise function for that. Next, we have a different quotient. That is 6 to 8. Right, different quotient is given by that formula. Right. First, we have f of x plus h. So let's write that here. The function f originally is something square minus 8 times something, plus 8, and then minus 9, and then we can put x plus h in it. Right. And we simplify this first, and then I'll put into the function later. Right. So x plus h squared plus ax plus hh minus 9, and multiply this out. X squared plus hx plus hx and plus h squared. Make sure we multiply this out. It is not x squared plus h squared. They are the middle terms here. So we have that. Right. So it will be x squared plus 2hx plus h squared plus ax ah minus 9. Right, so that's just f of x plus h. Just keep that column. Right. Now that is going to be this long function. And then subtract f of x. This is the original function, so it is just x squared plus ax minus 9 over h. Now just remove the parentheses and simplify. That will be minus x squared minus ax and plus 9. Have to change the sign of everything inside. We distribute the negative inside. Now, if everything works out perfectly, everything without an h got cancelled. So x squared here should cancel with something, and it does. The ax here has no h, should cancel with something, and it does. And the minus 9 with the plus 9. So everything left must have an h in it. Where we can factor out the h. We have 2x, h, and 8. Cancel out the h. And we have that. Right. As you see, there will be two important steps here. The first one is we cancel everything without an h. And the second step, we factor out or not, doesn't matter. The h at the bottom should cancel with something, and we should see those steps. Right. Keep going. We start with the same thing. The difference quotient. And let's look at f of x plus h. F of x plus h. The function f is 1 over 6 times something. doesn't matter what we put in for x, we put in for x here. Now we put x plus h, there will be x plus h, and that's what this one is. That's very simple, so I'm going to just put that here. And after that, minus f of x, this is the original function, right? So that is the different quotient. All we need to do is simplify this, and to simplify this, yeah, the color of them are different, but somehow look the same on the video. Alright, sorry. What we do here is to simplify this, and to simplify it, I will multiply by the least common denominator. So we have the denominator here and denominator there. The LCD is 6x x plus h. So we'll multiply that top and bottom. So it will look like this. We will not multiply the bottom, the denominator, because the h at the bottom will cancel somehow, should cancel somehow. Anyway, what we can simplify here is x plus h and the 6. So we just have x left. Next, we have 6x cancel here and here. The bottom we still have h, 6x, x plus h. Right, I'll remove the parentheses. The bottom is still the same. Cancel the x. And finally, we do cancel the h at the bottom. So it becomes -1, 6x, x plus h. And that's what we have. Right. In this one, we need to multiply by the least common denominator to simplify the complex fraction. Next, we have the square root of 5. 5 square root of x, sorry. Still start with the different quotient. This is unchanged. First, look at f of x plus h. It's going to be 5 times square root of something. And inside the parentheses is x plus h. So we're going to put x plus h. So it will be square root of 5 square root of x plus h, and then minus f of x is the original function, like this. Of course, we would simplify this and somehow cancel the h at the bottom. So the trick for that, when we have the square root, is we multiply something top and bottom as well, similar to this. But what we multiply this time is the conjugate. So pretty much almost the same as this. Except 1 minus and 1 plus. So that's the difference. 1 minus, 1 plus. So same thing top and bottom. Right. Let's just put the parentheses here. So we only need to multiply the top, because the bottom we need to cancel, leave the h there to cancel. So I'm going to write that first. So the first two terms here, so that multiply with that will be 25 square root of x plus h square of x plus h. I just want to write, because it multiplied by itself, it will be a square, and later on the square will cancel with the square root. Next, these two things will be plus 25 square of x plus h square of x, and then this 2 minus 25 square of x plus h square of x, and the last one minus 25 square of x times square of x is square root of x squared. The square cancel the square root, the middle term cancel. That is the reason we multiply by the conjugate, so the middle terms cancel. So this relation is called the conjugate. Right, I'll simplify this. We have 25 square root cancel this with the square, middle term gone, that's just x. Multiply it out, 25x, 25h minus 25x over the bottom, still the same. Right. Now that's just like what we have earlier. Anything that doesn't have an h will get cancelled. So cancel those two, they have no h. That leaves us with this. And then simplify the h. We have 25 over 5 x plus h and 5 square root of x. Actually, we can factor out the 5 and cancel with the 5 on the top as well. But the answer like this is good enough. Not do that in pencil. So this is good enough. But we can also write 25 over 5 square root of x plus h plus square root of x, and the 25 and 5 cancel out. We end up with 5 over square of x plus h plus square root of x. And 25 and 5 cancel. But the point is, if after we cancel the edge at the bottom, that should be good enough. And so this is good enough. This is a little bit better. Right, so that is the difference quotient. Right. Next, our transformation. There will be a lot in this test review. We're not going to do everything. Just first one is easy. Let you do it. Right. This one is a lot more complicated. Right, because we have to rewrite the function. So first, what I do is I have to factor out the minus, because it can only have the x by itself, like that. Because that becomes minus. If you factor out the minus sign, and then the minus 1. So we see that there will be a few things here. The first one, this is the minus. This minus inside the square root, so will reflect horizontally. Next we have the minus 2. This will go 2 units to the right, and the minus 1 here will go 1 unit up. Right. Next we just need to determine which one do we do first. By the way, we'll start with the square root function. So that's what we start with. Right. Now, notice inside, we will do inside first and outside. Inside, there is the minus multiplied to it and the minus 2. And always multiply, divide before add or subtract. So we're going to do reflect first, multiply first, and then add or subtract. And after that, we go on the outside where we only do that. So first we'll reflect this horizontally, so that we'll try to keep the color consistent. So we reflect this horizontally, so flip it the other side, and then move 2 units to the right. So that point move here, that point move here, so kind of like that. And finally, I apologize, this is minus 1, so this is 1 unit down. So this is go down 1 unit, and just go like this. 1 unit, so yeah, we start at this point. Because the transformation is a lot more important than the graph itself. Right, so reflect it, flip it horizontally, 2 units to the right, and then up 1 down. Sorry. Right, next we have this. We have the minus. This negative is outside of the function, outside of the parentheses. It's going to be reflect vertically. And then we have the plus 2 inside, which will be to the left, and the plus 1 here will go 1 up. And the other operation inside first, so we have to move first 2 units to the left, and then on the outside we have the minus. Actually minus is multiplied to it, so actually multiply by -1, so multiply and then add, and of course we multiply first and then we add. Right, so first move 2 units to the right, left, so that point left, that point left, this left, so smiley face there, and now we reflect that vertically, so flip it upside down. This is 4 units from the line and 4 units from the line. That, and finally we'll go up 1 unit, so this will be up 1, up 1, up 1, and the final we just make a little darker. So that's what we have. Right, just order of operation, and just order of transformation I should say, and then we just follow those transformation. In this case 2 units to the left, flip it upside down, and then go up 1 unit. Right, next find a function that finally graph apply to graph square root of x. So we start with the basic function that the graph is shifted down 6 units. That easy. That will go down 6 units. Reflect about the x-axis. That is with the minus. And then reflect about the x-axis. That's the minus. And finally 4 units left. That's it. 4 units left. So it has to be like that. Except, I'm sorry, this is reflect with the x-axis, so never mind. The minus is on the outside. So yeah, so reflect about the x-axis, meaning that is vertically. Yeah, so one is like this, the other one is like this. This is x-axis. Yeah, so we have the minus on the outside and not inside. Sorry. Anyway, so like that. I think with 25 easy, so I'm not gonna do that. And we did something like that in class. Right. And behaviors. 29. Right, and behavior we will look at the highest power term, which is that. This is a cube, meaning an odd, one up, one down, and it is positive. So the right, this is odd, so one up, one down, and this is positive 2. So it's positive 2. The right side is up, and because it's odd, one up, one down. So if it's positive, the right is up. If it's negative, the right end is down. So we look at this, we say that falls to the left and rises to the right. So just like that. I have a couple more examples here because I think 1 is not enough. So when we look at this, the highest power term is this. It is an even, so both of them will have the same behavior. So first thing we look at is negative. So negative, the right is down. And this is even, so left and right have the same behavior. So the left is down, the right is down. So we start with the minus, the negative, the right is down. Positive, the right is up. And then we determine the left behavior based on whether it is odd or even power. Right, if we have something like this, still do the same thing. Just take the highest power term. So we have negative 4x times x cubed times x, x times x squared times x cubed is x to the 5th. So we have negative 4x to the 5th. Let's see what happened on the left and on the right. First, it is negative, so the right is down. And this is odd, meaning 1 up, 1 down. Since the right is down, the left side is up. Right. So just look at the highest power term, and I emphasize the highest power term. That means not necessarily it's the first term, or we have to do something like that just to get the highest power term. Right. Next, the zero and multiplicity. This should be simple. Right. So just draw a little table here. We'll have zeros, multiplicity, and then there will be behaviors. So we have x plus 5, that factor equal to 0, and because that's just the first power. So 0 will be negative 5, because x plus 5, 0, x is negative 5, multiplicity of 1, and we cross the x-axis. Actually, just run the first one, we have the answer already. But let's finish that anyway. This, we have x equal to 5. Multiplicity is the power of the factor. It is even, so we will touch the x-axis and turn around. So if we have an odd multiplicity, we will cross the x-axis. If it is even, we'll touch the x-axis and turn around. Right. 28 is indirectly related to it. So let's say we need to do a few things here. The two things we just did, the 0 and multiplicity. So so x minus 2 square equal to 0, so x is equal to 2, multiplicity of 2, and it will touch the x-axis and turn around. I'm just going to write like that. That x plus 3 square equal to 0, we have negative 3, multiplicity of 2, also touch the x-axis. Alright, so we have negative 3 and then 2. Right, next, let's look at the end behavior and see what happened. If we take the highest power term, so x to the 4th, so pretty much both of them go up because it is even, so x to the 4th goes like that. So both of them go up. Or we say it is positive, so the rise up, and it is even power, so both sides the same. So left is up, right up. Now, if we know this is up, it will go like this. It will go down and go to 2, but at x equal to 2, it will touch the x-axis and turn around. And then it go back down to negative 3, where it also touched the x-axis and turn around. So by the look of the graph, we see that is all of them above the x-axis, except for those points. So we say below the x-axis there will be no interval, and then so more like going to be D. That is directly related to two things we just did, the end behavior and zeros and multiplicity. Right. The graph of polynomial function, that kind of like the thing we just did. Have to combine a few things. Next, vertical asymptotes. 30 and 31. Let's look at this. So to find the vertical asymptote, we need to have two things. The bottom equal to 0, but the top is not. So we need that for the vertical asymptote. Right. I'll look at 31. 31, we start with bottom equal to 0. If we solve for x, look like we can factor like this. Of course, I show you how to use this calculator to do this. So I have x equal to negative 4, x equal to negative 1. Next, we will check when x equal to negative 1, the top equal to, we'll put negative 1 in for x. and that is 16 minus 1, so it's 15. It's not going to be 0. That's what important, which is good, and that is a vertical asymptote. Now we check for x equal to -4 as well. X equal to -4 on the top, -4 squared, so that's -16 plus 16, and that is equal to 0. We cannot have the bottom 0 and the top equal to 0, so we cannot have this and we cannot have this. So we only have one vertical asymptote, is x equal to -1. Only have that. So make the bottom equal to 0 and the top is not. On 30, we start with the bottom equal to 0. And x squared is equal to 4. X equal to, make sure there's a plus or minus here. Right. You need to check to make sure that when you put 2 or -2 in here, the top is not equal to 0. So we have to do both of them. Right. So this, there's something left for you to do. So that is the vertical asymptotes. Horizontal asymptote, there will be 3 scenarios and very straightforward. I'm going to write this down. Degree on top, if it's less than the bottom, there will be y equal to 0 is the horizontal asymptote. If degree on top is bigger than degree at the bottom, there will be no horizontal asymptote. And if the degree are equal, we'll take the y equal to the ratio of leading coefficient, or the leading term. Right. So, or closely speaking, we say bigger on the bottom, there will be y equal to 0. Bigger on the top, there will be none. And when the exponential are equal, exponential are the same, then we divide the coefficient. So now those are the scenario. Bigger on the bottom, y equal to 0. Bigger on the top will be none. Otherwise, we divide the coefficient. So this one, degree on top is 1, degree bottom is 1. They're the same. So we divide the coefficient. So which will be y equal to 1. Very straightforward. I mean 6 divided by 1 is 6. That's too obvious. So divide coefficient 6 divided by 1. Right. Next, degree on top here is 1, and degree at the bottom is 2, and degree on top is less than degree at the bottom. Bigger at the bottom will be y equal to 0. And this degree on top is 5, the bottom is 3. Bigger on the top, there will be no horizontal asymptote. So very straightforward from this. If bigger from the bottom, bigger on the bottom, y equal to 0. Bigger on the top, there will be none. And if they're equal, we just divide the coefficient, divide the highest coefficient. And we just have that. So these 3 scenarios. The oblique asymptote is we require to have two things. First degree on top has to be one more than the bottom. And second, the remainder must be something else than 0. When both of these are true, then y equal to the quotient is the oblique asymptote. Right, so pretty much we check quickly on this example. Degree on top is 2, degree on the bottom is 1, and 2 equal to 1 plus 1, which is true. So that's one check. Degree on top is 2, the bottom is 1, and that's true. Now we just need to divide them to find the remainder. I use synthetic division. I put the negative number of that because when we do synthetic division, it's only when the divisor is in the form of x minus c. So compare this and this. C is equal to negative 4. Right. And then we have the coefficient 1. Right. When we divide, rub the first number, multiply, and then add, multiply, and then add. The last number is the remainder, and in this case we do have the remainder not equal to 0. Remainder is negative 4. And that is not equal to 0, so this one's good. And so the quotient is here, and that is going to be our solution. So going to be y equal to 1x plus 3, or just x plus 3. So oblique asymptotes, degree on top is 1 more than the bottom, and the remainder cannot equal to 0. We still need to divide them sometimes using long division. This because of the divisors x minus c, we use synthetic division, and we end up with remainder is not equal to 0, and the quotient is x plus 3. So that is our answer. Right. With that, we finish everything, all the topics needed for the first test. I hope that will prepare you for the first test. Thanks for watching.